Okay, cool. Okay, that's actually not what I want you guys to be looking at. So I'm going to be covering iterators, generators, and then async generators. What, 15 minutes? Is that what we're shooting?
Take as long as you want.
Alright, I have no idea how long this is going to take, so we'll take a leisurely stroll. So who's familiar with like async generators? We'll work our way backwards. Who's familiar with generators and iterators? Okay, cool. Okay, so iterators and generators are a, oh, that's crap.
This is a harmony thing, right?
Yeah, it's a harmony thing. That's probably, let me just show you the actually. So iterators and generators are a way, think of, so streams are kind of data across time. Iterators and generators are kind of like lazy loaded data. So basically you can say, give me the next one, give me the next one, give me the next one, until you reach the end of whatever your stream of data is. I'm going to cover iterators because that's the foundation that generators are built on top of. But there's kind of a weird thing where the iterator API hasn't been finalized yet, and they're actually not available in Node yet, even though the generator API is, which is what generators are built on top of. So if that doesn't make sense, don't worry, I'll show you examples. But before I go into generators, I'm going to just talk about iterators. So the iterator is a way to just iterate over an object, which is where the name obviously comes from. So if we have some very boring vanilla object right here, we could pass that object into an iterator, and then we can call next on it. And every time we call next on it, it's gonna give you a tuple for key value. So it's gonna be like A, B, right? And the next one, the next time you call it, it's gonna give you, C, D. And I would run this for you guys, except I can't because it's not supported yet. Which is, actually, I forgot that it wasn't supported yet. So, but anyways, you're gonna keep getting the very next key value pair every single time you iterate, which is nice. And so you could do stuff like, you can pass it into comprehension. So like an example I have down here, you could pass it into fast enumeration, where you kind of like iterate through an object, and then you get the key value pairs. Separately with comprehensions, you could get the key value pairs and store them into a key value. So instead of like the 4 var in object, instead you could get the key value and just access them directly in the language, which is nice. So it's just like a nice little convenience. Like iterators, for the most part, really simple. The one thing that I'm not addressing is here. I think it calls a stop enumeration error, or stop iteration error. Let's see, I think I have one open.
When you say not available, do you mean it's available in 11 or?
Oh, okay, so let's start there. So it's not available anywhere, even in Chrome. Well, so it's available in Firefox, sorry. But within the Node ecosystem, it's not available anywhere.
Okay.
And it's not because it's not available in V8 yet, because it hasn't been implemented yet, and the reason why it hasn't been implemented yet is because the API has been in flux. So there, for instance, one thing that they added, I don't remember exactly, my memory's a little fuzzy, but one thing that they added was that you could, no, sorry, this is generator. So, suffice it to say it's been in flux. I won't go too much into details because it really doesn't matter. Because most of what I'm going to be talking about will be generators. But the main gist is that iterators, you can keep iterating. If you iterate, so actually now that I think about it, I think the object next actually is going to give you the same thing that generators give you. Let me run my generator real quick. Yeah. So it's going to actually give you value done. So this one will be true. This is actually what changed in the API, how this was handled. And I will cover this, but just to give you an idea of what this API looks like. So this is actually what the API looks like. The basic gist here is that you get this done property, so you know when you're done, there's no more values to extract from the iterator. And when you do get true, you need to stop calling next on it, otherwise it'll throw. So, pretty basic. It's pretty much just iterators. You can pass any object in here, and what it's going to do is, object dot get home properties? Object
Has home property?
Get home property names. So basically, it's going to enumerate over the properties that are on the object itself. So like if I had an object, right? Anything that's not on the object prototype. So basically, what's immediately on the object, nothing from the prototype chain. So if you were to set something on object.prototype and you were to create a new object, I mean, I'll show you an example real quick, right? So object.prototype a is equal to true. So because I said on object prototype, it's available on B. If I were to do for var I in B, console.log, that's a horrible location for that. So if I were to like log out all these keys, it's going to give me A, even though it's on the object prototype. So typically what you have to do is, what we were saying was, give object.has own property I. Oh shoot, damn it. That's awful. It's b.has property I. And then you would log it out. So basically, thank you. So it's not going to actually log anything because there's no keys in B of its own, because everything in B is coming from the prototype chain. So that's what you would typically do if you want to iterate through an object, especially to guard yourself against people adding stuff on object.prototype. So why am I showing you this? Because the iterator will do that for you. So if I were to like set object.prototype.x, that would not actually show up here. It's only just going to be the actual values, the shallow values on the object. So that's nice. So that's good. Iterators, these are great in concept, but you can't actually use them yet. So why am I showing you this? So there's this concept called generators. And what generators are is a way to dynamically create iterators. And so the way you create a generator is through this function star right here. And you can create anonymous generators. You don't have to have named generators. But they're just like functions in the way that they look. So it's like function star. But the one thing that's nice about generators is that they give you this special property, or this special operator called yield. And so that's what I'm going to talk about. And basically, this is how we today can do generators in Node. The version that you can do this in is 0.11.3. So if I use N, but you can use NVM or whatever. But 0.11.3 is the earliest version that you can use it in, because 0.11.2 actually has the old version of the API. Again, I forget what it was that changed exactly, but that's all you really need to know is use 0.11.3. And so what we can do with these generator objects is same concept as iterators, except it's dynamic. So for some reason, let's say we had let's say we were iterating through a directory off Dropbox, and we were saying, give me the next file, give me the next file, give me the next file, but we might not necessarily want to load all of them into memory immediately. You could dynamically load one file at a time using a generator. That's a good example. So right now, this is not doing anything asynchronously, so I'm just going to show you guys what this looks like. But the way that you create a generator object, so terminology. So I just showed you iterators. This is what's called a generator, or a generator function, right here. And then when you call a generator function, you get back what's called a generator object, or a generator iterator object.
Does it actually run the entering line, or is this console log entering?
Yeah. No, it won't. It'll just create the generator iterator object.
So nothing actually, it creates the generator, but it doesn't actually run anything yet.
It's like a constructor, yep.
Okay.
So it creates the generator object, which is how I prefer the terminology I prefer to use, because it's simpler. So this will give you a generator object, which is basically an iterator, but the reason why we call it a generator object is because it's not backed by an iterator, it's backed by a generator. So, it's not backed by a real value, it's backed by a dynamic value. And then apart from that, though, the API is exactly the same. So if we do this, I will show you guys. So if I call.
Run option.
It must be
You need the dash dash
the function.
Oh, yes, thank you. Okay, so let's talk about that real quick. So in order to use generators, you have to use Harmony, which means you have to use the V8 flag. So if you're not familiar with the V8 flags in Node, use node -- V8 options, type grep, and I thought this was funny, harm, and that will give you all the Harmony flags. And the one we want to use is Harmony generators. But for convenience, because I typically, when I am in Harmony mode, I tend to use everything like let. So I will just be using -- Harmony. And for some of them, like let, you have to use strict mode. So pretty much whenever I'm using Harmony, I always use all of Harmony, and I always use strict mode. What's that?
It won't work unless you specify it as strict?
No, I'm pretty sure this will actually work if you don't specify strict, so let me just double check. The reason why I say that is because let requires strict mode.
So I think the star goes on the end of the function.
Is that what's going on? No, wait. Oh, you mean after the gen? Like that?
No,
I think it's-
you don't- next to function.
It's function star space
Yeah,
gen.
space.
Am I getting this wrong?
Yeah.
Like this.
I ran this. I think maybe I added the name. I have an example that's... So let's just do my normal example. I was trying to get fancy
Maybe
for you
it goes
guys, but we'll just do it without the name.
Maybe it was a strict part.
Maybe let's find out real quick. Okay.
Yeah, exactly.
Oh, I need to actually... Well, that shouldn't actually be a problem. I have a file that... Let's jump to my file.
What node version are you on?
Yeah, that's a good question. Maybe I'm writing like... Should be fine. Let's try my other file, just to make sure, sanity check. Same problem. Maybe I'm on the other versions. Okay. I'm not sure what I'm wrong about with the versions, but I'm going to hop back over. So latest,
Should have dashed.
I think I'm like 2011. Okay, so that's why I'm running. I'm not sure what's going on with the version. Sorry about that. But just to jump back so that we can test our theories real quick. So let's see if we need strict mode. I don't think we do. Let's go back to. Oh, that was not it. So yeah. So you don't need strict mode. I tend to use strict mode just because whenever I'm doing Harmony stuff, I use let a lot, which you need strict mode for. And then let's see real quick if we can do a name generator. Yes, so we're good. Okay. So everything was fine. My version was just wrong, which is odd. I thought that was the correct version, but regardless, you don't have to worry about it. So anyways, so we can see here, if we take out these next calls, what it's going to do is it's going to iterate through it till it hits yield. And once it hits yield, it's going to pause. So what you're going to see is that it's going to basically run everything up until the next cycle. So it's going to run these two lines, and then when we call next again, which we won't, just I'll show you, it would then call these two lines, and then it would call these last two lines. So I'm going to run this real quick without the extra next calls. You can see it just returned one time. So it executed entering, and then it gave me the value for one and the done of false. And then again, if I add these other two in here, you can see eventually I'm going to get a done of true. If I were to call next again, I get the exact same error that the iterator gives you. And one thing, I have to refresh my memory because I actually have not. So typically when I'm using async generators, I'm using async generators. So I have only used .send once. Okay. And so I'm pretty sure yes. There we go. Okay, so that's actually the API change. So the old API was that there was a .send, which would then be the value that the yield call would return. So what's happening is the event loop is actually being paused, and then it's going to re-continue when you call next. The old API would actually call .send, and you could pass a value in as the return value for yield. So whatever value, but instead the new API, which is much simpler, whatever value I pass to next will get sent as the value for yield. So when I console log yield 1, it is actually console logging here. Does that make sense? So we pause the event loop. We can do whatever we want. 10 hours later, if we wanted, we could call g.next, pass it a value, and then it would return as a value. And then it would continue processing. So what's happening on the second tick, or the second turn of the iterator generator, is that it basically logs out the value that's returned by yield 1, which is here. Then it logs processing, and then it yields 2 back out to here.
What about multiple arguments?
What do you mean multiple?
For
next?
Passing to next.
It doesn't support that, as far as I know. Yeah, you can pass an object, or an array, if you want to. Pretty much an array. And I'll kind of touch on that in a sense when I talk about async generators, like the way that we take this and move it to like a higher level like concept. But yeah, so for the most part, you can do this customly. If you want to do, kind of some functional style stuff, you could do that with this. So it's cool. And so actually, before I show you the API, I'll just talk to you like what the hack is, because it's more or less a hack. What the hack is that basically we use the generator API to allow for us to write synchronous style code, our asynchronous code in a synchronous style. And basically what the hack is that whenever we yield on a predetermined type of value. And so that type of value is either a promise or what we call a thunk, or it can be like an array or an object. And I'll go through the examples in a bit, but I kind of want to explain to you guys how it works first. The idea here is that if I were to yield a promise, typically the way that you would use async generators, like you might use something like co, and I'll show you an example with that, actually with co in a second. Then you would do like same concept where you do like yield, and let's say you're using a promise file type of thing, so like read file, let's say it's return a promise. You do something like that, right? And what co is doing internally is, I didn't do what I want to do. What co is doing internally is it's calling next on your iterator. So you give it an iterator object and it's calling next on it. And every single time it calls next, it inspects the value that you return. If it's one of these approved values, it will then like call promise.then, or if it's a thunk, it'll pass it a callback. And if you're not familiar with what a thunk is just a function. So let's say I had a function that I could pass a callback to. That's a thunk. So one example of why thunks are useful is that you can do fs.read file.bind null, and that will give you a thunk. To give you an idea, well, you'd want your value, right? And that would return a thunk. That would return a function that you can call with a callback. So that's the two styles that you typically pass to, is either like a promise or like a thunk. But basically what's happening is that internally, co is saying like, does this value that you returned have a .then property? If it does have a .then property, it's a promise. If it doesn't, try passing it a callback and see if that works. But that's basically the gist. And basically what happens is, then whenever that asynchrony, which is a term that I prefer to use, whenever that asynchrony returns its value later on, it then calls next with the resulting value, which would be here. So basically if you want to see like, theoretically what you'd have is you'd have like some function, let's say I had, so let's give you an idea of what this would be like, right? So it'd be like generator, and we'd call like generator.next, right? And then asynchrony. And then you'd call like .next. So actually it'd be like if asynchrony.then, then you call .then continue, or let's call it like resolve. Just to give you guys an idea what this would look like. Right, and then let's say you had a function resolve. And then you would call like gen.next value. And then I'm pretty sure this is a bad example because this API isn't actually accurate. It's like the old API. Yes, top throw. Okay. So you basically do like, let's say that you have like your revolve. So it'd be like if error return gen.throws. Is it not dot throw? Then do that. So let's see. And if you're doing promises, you do like solve dot find null. Null, is that what we want? No. That's actually what we want for the other one. Find. Right, so this is like a really dumb, very, very quick implementation of what Co is doing internally. And then it's basically like doing this in a loop until the next value is giving a done of true. So just give you guys an idea of like what Co is doing internally. There's other libraries besides Co, so let me show you Co real quick. So I'll actually walk through this in a sec, but here's Co. TJ Hallway Chuck, Vision Media, Co. I don't want to scroll down too much because I'm going to show you guys API in just a second, but the other one that I use is Gens. There's a slight difference in the API, so I'll go over that in a second, but that's just another example. So then I'm going to show you guys the actual API real quick. Actually, it might be better just for me to walk through the Co documentation. So now that you know like basically what it's doing under the hood, I'll show you guys basically how you can like write this magical synchronous looking asynchronous code. So here's what it looks like. It's really straightforward. It's exactly what you would expect. Basically, you can yield on asynchronous values. So asynchrony, as I prefer to call them. It could represent a promise or a thunk, and then a few other like special types like arrays and objects. But basically, you get to write code that looks synchronous that's actually asynchronous, which is really nice. So for serial execution, you just do yields one after another. And then for parallel execution, you just yield on an array of asynchrony.
So that continues until there's an error, basically?
Continues to error. What do you mean?
Like for example, the one in the middle.
This guy?
So there's an error getting the first one. Is it going to stop or is it going to?
Yeah. If there's an error, it'll throw. And what's going to happen when it throws Co, depending, I think Co. So there's you can pass a callback to this to Co. So like when you invoke Co, you can pass a callback and you can pass it like a error back. And so you can get the error there. I think if you don't pass it an error back, it will actually throw, like code will throw. I don't know because it's all very implementation dependent. But yeah, so if this were to throw, it would not continue executing.
So the last one, like the cloud up, that's going to return basically done true, and it's going to stop at that point?
This one? No, this one will just return the value of cloud up. And then when you call next one more time, whatever the return value was, because remember you can have a return value. Let me hop back over real quick to mine. So remember, I had a return value right here. So you can actually have a return value at the very end. So that once you get a return value, that will be done true. I'm going to hop back over. So yeah, so they don't have a return value, but you could have a return value. So if you call next, you get this value next, you get this value next, you get this value next, you get the return value, which is undefined.
So this basically saves you from calling .next a bunch of times.
Yeah, but really what it's giving you is something that like, it gives you the ability to do asynchronous code synchronously.
Right. So is there any way of knowing what is the index inside that function? Inside the generator? Like which yield I'm on, whether I'm on yield 1, 2, 3, 4.
What's that?
So let's say I'm doing pagination
Yeah.
over here.
Yeah.
So how would I know the index?
Like which one you're on?
Yes.
I don't think there's a way to do that because it's dynamic technically, right? You could have a for loop that just yielded every single time you went through the for loop, and then you could arbitrarily like decide on every odd number I'm gonna not yield, or I don't know, right? Like so there's no static index, right? And as far as like where you're at in the code, it's more or less just like whatever code is being executed. So there isn't any. It's a short answer.
Okay.
So yeah, so you can do serial in order by calling multiple yields. You can do parallel by yielding on an array of objects.
Right there?
What's that?
What's the last one there?
The array.
Oh.
So this is for doing
That
parallel.
does
Yeah.
zero. Oh,
So what's
parallel.
nice there is that you say like I have 10 asynchrony. I want to wait on all of them.
Gotcha.
So what's nice is you get both the power of asynchronous code with the logical top-down flow of synchronous code. So you can like just follow top to bottom, and it's very easy to follow.
How do you do effectively error handling?
What's that?
Error
Error handling? So because it's synchronous, you could wrap it in try-catch. Try-catch is a tricky animal depending upon how you feel about it because Z8 will de-optimize any function that contains a try-catch, but it only de-optimizes the function that contains it, not like the whole file. So you can do tricks to get around it if you want to do a try-catch. Bluebird does it. I do it in try-catch, my try-catch library. Basically what you want to do if you do want to use a try-catch and you don't want to get de-optimized is you end up creating, let me show you what I do. And it's the same thing that Bluebird does. It's a total hack, but it works. It's unfortunate because I would like for V8 to support I would like for V8 to optimize functions with try-catch, but basically this is more or less what you do is you create these kind of like one-offs to basically say run this function in a try-catch, and that's all you do in this function. So even though V8 will de-optimize this function, you're not doing anything in the function, so it's not really a major performance hit. And instead of throwing the error, you just return the error. So it's a hack. But you can do that. So what you would do, so let's say hypothetically you wanted to use this hack, you would basically, let me show you real quick, let's go here. So let's say I had a bunch of code, it'd be like, so you can't do yield at a lower level, so actually I don't know if you could do this. And maybe this is probably something that somebody should support. Maybe somebody needs to do that, but yeah, because what I would say is that you would do something like let's say you had something like this, but the moment you go into a function, you're going to lose the ability to use yield, because yield can only be used within the generator closure. So you couldn't do something like this, and then get the value.
Oh, it has to be top level?
Yeah, it has to be top level, which is just a limitation of the API, so that way you know exactly like what you're yielding to. So maybe you could write a function, and it hasn't, there's none that I know of that does it, but basically let's say you had like, this would be a promise version, but let's say you did something like this, so that acted as like a pass through. Well, yeah, you'd have to figure that out. So short answer, you'd have to figure it out. Because most of the asynchronous generator APIs, they just bubble the errors. So the errors will go to like a callback, so that's how they handle it. And you could do a try-catch, that would work just fine. You'd have to worry about de-optimization, which, depending upon what your needs are, may or may not be a concern. So there's that aspect, so trade-offs.
How can you tell which one failed? You need to throw different errors, right?
What's that?
How can you tell which one failed?
Yeah, you'd have to throw different errors, yeah. So you could have to throw different error types, different error codes, different error strings, yeah.
And the thing is like, to me it's like, I like how the syntax become clean, but as soon as become, you want to do like a little bit of defensive programming and manage all the error condition, it becomes complicated again.
Yeah. I mean, if you, if you write your generators in such a way that they kind of behave as a transaction, it's not the biggest deal if one of them fails, but like you're saying, like, yeah, you don't have, without supporting error types with code or strings or instances, like you're going to lose some degree of visibility into what's failing. But to be honest, like when I write asynchronous code, like in step or step up or almost anything, I tend to coalesce my errors anyways. So because I'm coalescing my errors across multiple transactions, like or multiple asynchronous calls, like it's not. But yeah, but it's a valid point though. So, what can you yield on? This is Co's API. I'll point out what Co does that is mostly similar, and then I'll point out what Gens does and why Gens does it, and I try to explain it. But for the most part, is the two that you care about is promises and thunks, and then you can actually yield on a generator and a generator function. So if you yield on a generator function, it's just going to immediately invoke it and create a generator object. If you yield on a generator object, it's just going to basically yield the return value. So does that make sense? Again, I'll pop back real quick. So let's say I had this generator.
Those are all the types that it will keep going on otherwise, right?
Exactly. Those are all the yieldable types. So let's say I had this. Oh, sorry. So I could go like yield. I could yield on gen because it's a generator function. I could also yield on gen being invoked because it's generator objects. And then of course I could yield on like normal values like that, although there's no reason why you would normally do that, but then I could yield on promise and yield on thunk. That gives you an idea. So the last two, which are for parallel execution. So arrays are really straightforward. If you yield on an array of any of these over here, you're going to get an array back. So let's say you had yield, let's say you had like a promise that A, B, C, you get an array back that returned the values of A, B, and C. Same for thunks.
I don't see a number listed in that. You have yield one.
Yeah, sorry. I actually don't think this is supported in Co.
Okay.
Sorry. I don't think primitives or like immutables or anything like that are supported in Co. So the last one is objects. Object is one thing that's different between Co and Gens, and I'll talk about that first in Co. I think he has an example in here. Yes. So objects are, you can yield on an object tree, and it will basically traverse the object tree and find any asynchrony within the object tree, and then just wait till they're all resolved. So here we have an object tree, and we have two asynchrony buried at a deeper level than the top level, but it will still wait for them to be resolved, and it will then return an object that is, so like user.name.first would equal to whatever the asynchrony returned for that value. Which is kind of nice, because you maintain like key value like associations, instead of having to like kind of go to a lower level like tuple with an array and then come back up to like an object representation. Instead you can just like leave it in an object representation and not worry about it. So in theory what you can do is you can have objects that you basically like hydrate, so to speak, right? Say like, oh, these objects have a bunch of like thunks to database calls or something like that, but go get them. Go hydrate this object. And again, you could do it sequentially too. This is a weird example because conceptually you're thinking like this is an object, this is one operation, but the way that the parser is going to encounter these is going to see this yield first, and it's going to see this yield second, so it's actually going to execute this first, wait on it, and then execute this second. A little weird, but that's basically what you could also do if you want to do them serially. So that's pretty much the entire async generator API. I'm going to talk about one slight deviation, which is Gens. Gens does one thing different with objects. Oh, he doesn't have it documented. So I'm going to hop over to the async gen. So Reynos and I wrote a spec not a long time ago, it was like 6 months ago, basically to kind of like formalize all the API. It never really took off, partially because we refused to specify this asynchrony types. Like we were trying to avoid saying that it has to support promises and it has to support thumbs. We were trying to leave that open for implementation. But the one thing that we were separating, and this is what Jens does, and I'll try to find it. So, and it's really unfortunate because this should really be like an example. But we were using yielding on an object as a special way to, as an error channel, but as a non-crash necessary error channel. So basically, instead of throwing, you could, it would intercept errors that were passed to callbacks or passed to promises, and basically you could intercept them by using the both key on the object. It's a little awkward. Jens does it. It's not documented. I'm not even gonna like really touch on it because I'm still kind of like on the fence about it. But I will just say that because if you do use Jens, I think Jens is a great library, but it does do that slightly different. The idea is just simply that there's a class of errors like in promises that don't require a crash, and there's a class of errors like something that happens in core that does require a crash. And we were basically trying to create separate error channels for each of those. And that's what we used yielding on objects for in the async gen spec. So that was that. But yeah, so like just to hop back to so you guys can actually see this running. Here's an example. This is using thumps. So you can see, I'm gonna run this real quick. And basically it runs, for lack of a better way of putting it. So I'm using the request library, I'm using co, I'm reading a file, I'm getting google.com, I'm doing them in parallel with an array, I'm logging out the headers, and then I just return success. And you can see here that when I log down here, so the return value for my generator function is getting returned to the callback. So you can see I'm logging it out here. Separately, if I were to you get the error. And it's logging it here, so let me show you guys real quick. So now we're not crashing, we're actually logging undefined because I'm logging the error out and then logging result out, which is undefined. So just to show you guys that this is the logic. So if I throw inside of my generator function, it will return success. So let's do one more example before I go to just the promise one. So let's say I have like function C, which will be a thunk, so it'll take, and then it'll process documents, take and error. So instead you see that when I yielded here, it never proceeded because C returned an error even though it was in its callback. Even though I didn't throw it, I returned the callback, and that got coalesced down here into the callback function.
So does that mean, because normally with requests you get, in the callback you get an error, if there's an error, and then the result,
Yeah.
the response, right?
The response, and you even
So-
get the body, so there's actually 3 values.
So it's bubbling up the error, and that it would work the same way in this case?
Yeah, exactly. So it's both coalescing the errors, because if any of these 3 error, you're going to get 1 error. So that may or may not be a good thing.
Yeah.
And then separately, it's also like bubbling it up, meaning it's not proceeding down as well. So yeah, so like you can do this without any libraries. You don't need promises. If you don't use promises, you have to call like .bind or some type of like equivalent to that. Separately, if you do use promises and you do like promises, the one thing that is nice about promises with regards to this is that you can call .promisify all, which means that you don't have to call .bind. You can just call the functions. So that's nice for core functions. So this is going to execute exactly the same way. So let me run this real quick. Oh, I actually need to include it. Actually, I think I can do this. I know I can do this with Q, but I prefer not to use Q. Actually,
What's Bluebird?
Bluebird is a minimum promises A plus implementation that is highly optimized for performance. So those try-catch, the V8 try-catch de-optimization hacks that I was showing you guys, Bluebird does those to make sure that, because promises wrap every single callback in a try-catch, so that way they can always like handle all the errors and pass them down the chain. When they do that, they create a bunch of really slow code because everything's getting de-optimized. If you look at the source for Q, basically, more or less the whole function's getting, the whole code base is getting de-optimized, the whole module. Whereas with Bluebird, only the few functions that they create get de-optimized, so the most of it gets optimized by V8, so it ends up being really fast. Anyways, long story short, Bluebird is mostly just a minimalistic, fast version of the promises. So I think this will work. Let me try it real quick. Oh, copy and pasting. Oh, I think you might have to call it on each individual object. So let's just try that real quick, just to make sure.
So that's wrapping all the functions?
Yeah, it's supposed to be wrapping. Actually, I only use Bluebird occasionally. Let's try Q. I'm not sure what I'm missing. I know Q at least has it documented.
You're smart enough not to wrap it twice?
You can tell I use promises a lot. Has anybody used promises? Done this before? Nobody? Okay, if nobody used promises, I won't go into it. I know you can do this. Since nobody uses it, nobody probably cares that much. I know you can do basically equivalent to this, where you call it once, and it will promisify all the core functions. And if you do that, then you can basically do stuff like this, where you can pretty much call it without the dot bind, and it behaves exactly the same way, which is nice. So that's all I was trying to get at. So that's pretty much it.
Questions? Ruby's mind is blown. No
It's
mind.
really simple, yeah.